Hey everyone, and welcome. Today, we're going to try and get a real handle on this huge, exciting, and let's be honest, kind of confusing field of artificial intelligence. And we're going to do it by going straight to the textbook that has pretty much defined the field for decades.
I mean, you see the headlines about AI everywhere, right? Super smart machines, breakthroughs that are going to change the world. It's really easy to get lost in all the hype. So what is AI, really? Let's cut through all that noise and get to what's actually going on under the hood. All right, so here's our game plan. First, we'll try to pin down what AI even is. Then we'll get into something called the rational agent, which is really the main character in the story of modern AI. After that, we'll do a quick tour of AI's roller coaster history, peek behind the curtain at how it actually solves problems, and then wrap it all up by looking at where AI is today and where it's headed.
So, first things first, what is artificial intelligence? You know, the most important thing to get is that AI isn't just one thing. It's this massive field of study, and the way we've defined it has actually changed over time as scientists chased different, sometimes even competing goals. You can pretty much lump the different goals for AI into four big categories. On one side, you had folks who wanted to make machines think just like us humans, and others who just wanted them to act like us. That's where the famous Turing test comes from. But then there was this whole other camp with a totally different aim, not to be human-like, but to be rational, to think or act with perfect, undeniable logic. And it's that last one, acting rationally, that has become the absolute bedrock of modern AI. The point isn't to create a perfect human copy, but to design a system that makes the best possible decision to get the job done. There's this fantastic quote from the textbook that just nails why that shift happened. The quest for artificial flight succeeded when engineers and inventors stopped imitating birds and started using wind tunnels and learning about aerodynamics. Think about that for a second. We didn't get airplanes by building giant mechanical birds that flap their wings. We got them when we understood the deep principles of flight. And it's the same thing with AI. The biggest breakthroughs have come from focusing on the principles of rationality, not just trying to build a perfect human impersonator. So if the goal is to act rationally, how do you even build something to do that? Well, this brings us right to the core idea of modern AI, the rational agent. Okay, so what on earth is an agent? It's way simpler than it sounds. An agent is just anything that can sense its surroundings and then do something about it. Your thermostat? Yep, that's an agent. It senses the room's temperature and acts by turning the heat on or off. A robot vacuum is an agent. But the key distinction here is what makes an agent rational. A rational agent doesn't just act, it acts to get the best possible result. It's basically an optimizer, always trying to get the highest score it can. And to design these rational agents, engineers use this wonderfully simple tool called the PAAS framework. Think of it like a job description for an AI. You have to define its performance measure, how it keeps score, the environment it operates in, the actuators it uses to make a move, and the sensors it uses to see its world. PAAS. Simple, right? Let's make this feel a little more real. For a self-driving car, what's its performance measure? Well, safety, getting to the destination, maybe even comfort. The environment? That's the roads, traffic, people. Its actuators are the steering, accelerator, and brake. And its sensors are all the cameras, GPS, and radar. See how that all fits together? The same framework works just as well for a medical diagnosis AI or even for those much older expert systems. It's a universal blueprint. So, how do we even get to this point? The history of AI isn't some nice, neat timeline. It's a real scientific quest, full of amazing highs, some really crushing lows, and these incredible moments that completely changed what everyone thought was possible. So it all kicked off in 1956 at the Dartmouth workshop. That's where the term artificial intelligence was born. But all that early excitement pretty quickly slammed into the reality of just how hard these problems were, which led to the first AI winter when the funding dried up. The field fought its way back in the 80s with these things called expert systems that were actually making companies money. Then, a huge moment for the public. 1997, IBM's Deep Blue beats the world chess champ Garry Kasparov. But the real explosion, the one we're all living through, started around 2011. They called it the deep learning revolution, and it was powered by two things: unbelievable amounts of data and computers that are almost unimaginably powerful.
Okay, so we've covered the what and the why of AI. But what about the how? How does an AI actually solve a problem? I promise you, it's not magic. For a huge, huge number of problems, the answer is surprisingly straightforward. It all comes down to a systematic process of search.
Just imagine you need to find a driving road on a map. An AI looks at this as a search problem. It has an initial state. You're in the city of Arad. It knows the actions it can take, drive to one of the connected cities. It's got a transition model, which is just a fancy way of saying it knows that if it drives from Arad to Zarind, it will then be in Zarind. And finally, it has a goal test. Am I in Bucharest yet? The AI's whole job is just to find the chain of actions that gets it from the start to the goal. That's it. But how does it explore all the options? Well, there are two main flavors of search. The first is uninformed search. You can think of it as blind search. The agent literally has no clue if one route is better than another, so it just methodically tries everything. But the second kind, informed search, is much, much smarter. It uses something called a heuristic, which is basically an educated guess or a rule of thumb to estimate how close it's getting to the goal. It's the difference between trying to solve a maze with a blindfold on versus solving it with a compass that's always pointing you toward the exit. It's a real game changer. So these basic ideas, rational agents, search algorithms, they're like the Lego bricks of AI. And today, with all the computing power we have, those bricks are being used to build things that are moving forward at a pace that is just mind-boggling. Which brings us to AI today and tomorrow. To really get what's happening right now, you have to absorb this one stat. For decades, we talked about Moore's Law, computing power doubling every 2 years or so. Well, for the biggest AI training models, the amount of computer power being used has been doubling roughly every 3.4 months. That's not just faster, it's a completely different kind of growth. It's an explosion, and it's fueling everything we're seeing. And that explosion is leading to some jaw-dropping results in the real world. In complex strategy games like Go and StarCraft 2, AI has blown past the best human players. In understanding images, AI's error rates have plummeted from almost 30% down to 2% in just 7 years, meaning it's now better than humans at some of these tasks. And in medicine, AIs are now performing at the same level as expert doctors for diagnosing certain diseases from medical scans. This isn't theoretical stuff. It's here now.
And nothing captures the feeling of this new era better than this quote from KG, who was the world's #1 Go player. After losing to Google's AlphaGo, he said, "Last year, it was still quite human-like when it played, but this year, it became like a god of Go." I mean, just let that sink in. It's one thing to be beaten by a smart program. It's something else entirely to feel like you're playing against a god. And this incredible, almost godlike power leads us to one of the trickiest, most profound challenges in the entire field of AI. It turns out the more powerful an AI gets, the harder it is to tell it what you want it to do correctly. Decades ago, a mathematician named Norbert Wiener warned us about this. He wrote, "We had better be quite sure that the purpose put into the machine is the purpose which we really desire." This is the classic King Midas problem. Midas got exactly what he wished for. Everything he touched turned to gold. He just forgot to mention that he didn't want his food, his water, or his own daughter to turn to gold too. And that leaves us with the ultimate question for the future of AI. The biggest challenge isn't just about making machines more powerful anymore, it's about making them wise. How do we solve the King Midas problem? How do we communicate the incredible nuance and complexity of what we, as humans, truly desire? Finding the answer to that question, well, that's going to define all of our futures.